Hi everyone, my name is Kuha. Um, I will be your instructor for this HR analytics project, which is a hands-on project that we have prepared for you to really apply what you have learned so far in data analytics and apply to some of the real projects. Through this project, you will learn how to start from the beginning, start from the scratch by importing a data into the Jupyter Notebook, and then use various tools to clean, analyze the data, and then create some visualizations to present to the company stakeholders. And finally, draw some actionable conclusions and recommendations for the leaderships. Through this project, you will learn a various process that is commonly used in the data analytics. Not just that, you will learn how to deal with some of the edge cases, as well as how to best present your data visualization so that non-technical, cross-functional stakeholders might be able to understand what you're talking about, and then you can have as much impact as possible. This is pretty core process when it comes to data analytics. And keep in mind that all the functions, not all the functions that you've learned will be applied here. Neither all the functions that I'm going to be going over, you have already learned. But it's more of real world projects that you'll get to really learn and experience to understand what is it really like to run data analytics using some of the real world like data. So we're going to be going through these steps. First, we're going to learn how to do a data import. We're going to be importing our data from a CSV file into the Jupyter Notebook. And then we're going to be exploring the data through the process called EDA, exploratory data analysis, which is a crucial step in understanding what kind of data that we have and how to pre-process and clean the data to make a best visualization. And as I said, we're going to be processing cleaning data to best prep for the insight building and visualization. And then we're going to be using some visualizations tool to build nice plots and charts so that you can easily share these plots and charts to other stakeholders. And then from this plots, you can draw a nice conclusion and recommendation for the leadership. So let's get started here. So the first step is to import the data. We're going to be importing data from your local repository into the Jupyter Notebook. And I have listed here some of the most common file formats that you can import and the corresponding functions. So for example, one of the most common file format that we use is CSV file. CSV file stands for comma separated file, which means each of the inputs are separated by comma. And there is a function within the pandas called pd.readCSV, which automatically translates that comma separated format into the data format that you can easily digest and use. Similarly, we can also do the same process with Excel file by using read Excel. And if you have other formats like JSON or HTML, you can also do that. And if you're also dealing with some other data format, I'm pretty sure there is a pre-built libraries such as these already exist. So you can just Google search or use the tools to find out which function would be appropriate for that file. But for today, we're going to be focusing on CSV file, which again is the most common file. So I already made a pre-template for this project. So I already have some of the core libraries here to play with. I have NumPy, which is a core libraries where we use to calculate, and we have Pandas, which is a library that is super useful when we're doing data analytics. It creates a data frame and it comes with a bunch of functions that is very useful in data to analyze data. These two libraries, Seaborn and Matplotlib, are two commonly used tools to plot out the data. Matplotlib, I would say, is more of a default when you try to plot anything in the Python. However, there's more fancier version called Seaborn, which is more again like has more complex and more user friendly functions to it, and it usually outputs more prettier plots. So we're going to be using both in this case because you will most commonly use both interchangeably. So the first step is to import the libraries, and I'll run it here. And then next, I will run these functions, read CSV, which I already talked about, to import the CSV files. So we have 3 CSV files here. We have 2 more that we're going to be covering later, but for now, let's focus on these 3. We have employee survey data and manager survey data and general data. I also provided you with a Excel file that lists more context behind each of the columns listed here. But let's take a look by importing these files. So I ran that query or code, and we can first quickly take a look at the file using the head function. So if you use a head function, it will display the first 5 rows of the specified data frame. You can see that it's already showing the first 5 rows along with the columns. So you can see there are 4 columns here: employee ID, environment satisfaction, job satisfaction, and work-life balance. You can see that employee ID, he's here, which we know that it is a unique ID given to each of the employee. And I do see the different scores or survey results, which specifies whether the user liked the environment, work environment, was user or the employee was satisfied with their job, and do they have a good work-life balance. Here, the higher the score, the better it is. For example, if you have a score of 4, it means you have a better work-life balance than score of 2. So now let's take a look at the DFM, which is manager survey data, see what that shows. So here we have a similar format of employee ID and also job involvement and performance rating. And this is most likely the survey that manager gave out to the employee on how they're performing and also how involved they are with the job. And lastly, we have the general data.csv, which is imported into df general variable. So if we take a look here, this is actually a much larger data set. It has it's currently only showing 5 rows, but it has 24 columns, and this 24 columns all describes um, the employee. Is basically an attribute of that employee. And we see here attrition, which is like a target variable or a target feature that we're interested in. Attrition is equals to yes, then we know that the employee has left the company. If it's equal to no, then the employee has stayed with the company. And this is a core output that we're interested in. And the goal of this project is to understand, okay, we have this different data set that describes the employee. We have this employee survey data, manager data, and overall general attributes of the employee. And can we find any patterns or significant insights we can draw from here to recommend to the leadership of the company, hey, we noticed that most of the employees who left shows this kind of patterns or this kind of attributes. Therefore, we should do X, Y, and Z. So that is our end goal, and um, That is our end goal. So let's dive into it. Now, let's go to the next step, which is exploring data set or EDA step. Data exploration is a crucial first step before we do anything with the data because we got to first understand the data, what kind of data that we have, in order to really plan out what we want to do with the data, like, for example, cleaning and pre processing. The goal of the initial data exploration is to understand the structure, quality, and characteristic of the data set, enabling us to make informed decision about handling missing values, outliers, and inconsistencies. This process ensures that the cleaning efforts are targeted and efficient, prevent unnecessary modification that might distort the data set. Effective data exploration leads to a better pre-processing and ultimately improving model performance and insights into data analysis. And I have listed some of the common methods to explore the data. Again, just to let everyone know that these are not the only ways you can explore the data, but one of the common methods that I use and most analysts use in order to explore the data in Python. First, I already went over this, but we can use dot head to take a quick look at the data and this function shows first X rows of the data set. You can specify a number in the function if you want to see any other number of rows other than five. The next, there's a df dot describe. So dot describe function shows a numerical statistics of the data set. I'll be showing you how it's used really soon, but basically it shows all the core statistics of the data set, but it only shows that statistics for numerical columns like float and integers. Next, there's .info function. .info is a built-in pandas function similar to describe and head, and it shows what kind of data type the each columns are in the data frame, and it also shows how many non-null values there are. And we can also use data visualization tools like basically plot out the histogram and box plots or any other plots to really understand, hey, how our data is distributed or if there's any like weird values within our data, etc. It is like easy and quick and easy process to take a really high overview of your data. And it would also give you like a preparation for the real or final output visualizations. So it is nice to do in the beginning to see what kind of visualizations the data will output. And lastly, you can use dot value counts by specifying a specific column name here. This function basically shows a histogram or value counts within each column. I think it will make more sense when I actually show you here. So let's put these into an action. So let's see. Let's first look at the employee survey data, DFE. DFE, and then we already used head, so I'll skip that. And I'll go into describe. As I said, describe shows a numerical value, a numerical column is only. Right now, it's only showing employee ID. And let's see what kind of statistics it's showing. It's showing the count. It shows how many non-null values there are in the data set or in the specific column. And it shows mean, standard deviation, min and max value, and different percentile values. It's very useful to have a quick look at this distribution of the values within the column. This is something that is interesting because when we run the DFE or DFE head, um, you can do either. You can see that there are four different columns, and it looks like three of the columns that is not showing on the describe function are numerical. So let's see what's going on here. So let's take a closer look at the data frame using an info function. Once I run the info function, it's going to show four different columns, basically all the columns within the data frame. and it will show all the non-null values. So there are 4,410 non-null values. So all the columns have the same number of non-null, which most likely means we don't have null values inside this data frame. However, this is very interesting how the data type is showing. The first column is an integer. That's why it showed up in the describe function, but the rest are object. Object basically means is a string. It is not a numerical value. So the computer or Jupyter Notebook or the Pandas doesn't really recognize this column as a numerical value, but it recognizes as object type. So later we need to remember this, and we need to make sure we convert these columns into a numerical value so that we can take statistics, or we can basically run analysis and on this data set. Let's take a look at DFM data set, and let's go to describe. So when we run describe function with the manager survey data, you can see that all the columns are showing, which means all the columns are numerical values. You can see that the job involvement, which shows a score of employee, ranges from 1 to 4, same as a performance rating. There's nothing much to note there other than that. We're going to be looking more closely later on when we do the analytics. So let's go into DF general, or let's just confirm if they're actually numerical values. And you can see all 3 columns are integer data type. And similar to DFE, the employee survey data, there's 4,410 values, which most likely indicates there are 4,410 employees in this company. DF general, let's do a describe. Let's run it. So this data set has a lot of numerical columns. First, let's look into the age. This is interesting. The mean age of this company is 4,000 years old, which doesn't make sense at all. And you can quickly see that this is most likely due to the fact that are people who's written as having an age of 9,999, which is probably erroneous data, some sort of system error, data entry issue. It's showing 9999, which is clearly not reasonable and faulty data. Therefore, we should remember to do something about this data points. And we're going to be learning how to deal with this kind of erroneous data later on. And I'll quickly skim through and see if there's any weird or something that comes to my eyes, anything weird showing. But yeah, I don't see anything weird just pop up in my eyes. Maybe we'll catch something else later. So this is basically some of the tools that we can do we can use to do a quick EDA, basically exploration of the data. And so we first discovered these 3 ways of dealing with the data analytics. Now let's go into visualization and value counts. Before we go into visualization, let's talk about the value counts. So how you use value count. Let's go back to the manager survey data. So let's say that we are curious on how many employees received for performance rating of 1. If we're curious about that, we can simply use the value counts function. First, we need to specify a specific column that we are interested in. So we are interested in performance rating, and we just type in dot value counts, which will output basically the value count distribution of how many of each value is within the column. So for example, majority of the employees have performance rating of 4. However, there are some employees with 3 and 2, and small proportion of the employees have performance rating of 1. So this means this is like basically a quick way of seeing how the values are distributed within the column, and this is very useful tool when you're quickly taking a look into a data set. All right, now let's move on to the quick visualization we can do to understand the data. So right now the goal is not to create the best plot possible, but just to use a plot or visualization tools to understand the data. So let's see, let's choose one of the columns. So um, let's take a look into the age column within the DF general data set. So again, well, we have these two different libraries that we can use to plot. Let's first use this matplotlib.pyplot to plot out the histogram. Since we have imported this library using an alias or using the name PLT, we can simply use plt.hist. Basically, it stands for histogram, and assign input the data that we are interested in converting into histogram. So let's do a df general and age. So now when I run this, it's going to show a histogram of df um, age within the df general dataset. Unfortunately, this histogram is not showing much other than that there are large proportion of the data which is showing 9999 um, as an age. So we know that we need to deal with its data. Let's take a look at other column. So we're looking into distance from home. Basically, it tells you how far the user lives or employee lives away from the company. Um, and you can see the majority of the employee lives with very close to the company. I'm assuming this is in kilometers. It could be in miles. I have to take a look into the data context. But regardless, majority of the employees live close to the company, and um, and the distribution drops from there. So it's a heavily skewed to the right data set. And we always like to use plt.show at the end of the core end of the code, because that basically cleans up any other unnecessary output, and the plot might show. For example, like if I run it without the plt.show, if I comment it out to make it inactive, if I run this, and you can see there's like a lot of unnecessary output that is showing. So if I just want to see the plot, um, then I just run plt show, which will only show the plot, and then I can use other functions like plt title, which basically assigns the title to the plot that you're plotting and give a name. So I want to name this plot a distribution of distance from home, and I'm gonna assume this is for kilometers. So if I run that, now has a title that we have assigned to the plot. So this is a very useful tool and process. There are other functions that we're going to be going over to make this plot more legible and more understandable. But we're going to be stopping here for now because our goal is not to, again, not to create the best plot ever, but to really understand the data. So let's try to use a for loop to basically create a histogram of all the numerical value columns inside of the DF general data set, because that would help us, because we don't want to go individually copy and paste the column name and create the data set individually, create the plot individually. We want to make automated process so that we don't have to do it over and over. So I'm gonna be controlling Z to get back the comment that I used. So here, I'm gonna be using a for loop to um, basically loop through some of the core or some of the numerical columns that I'm interested in. I'm gonna be calling the list of column names called numerical column names, and I'm gonna create a list, and I'm gonna copy and paste some of the columns that I am interested in. So the first column will be age, and then I'm gonna be plotting out distance from home. Then I want to plot out, let's choose something else. Let's see, years at company. And lastly, last years since last promotion. So I have basically pulled um, the list of column names into a list and assigned it to the column name variable. And I can run the for loop on this list. Basically, I'm running a for loop on this list, and each time each column name will be named call, and then I can use a plt histogram, plt hist, to plot out those columns. So instead of manually specifying the column name here, I'm going to be automatically doing that using a call, and I'm going to be naming the title, basically titling it um, using the column name again. Let's see what happens if I run this. Nice. So as you wanted, now it's plotting four different histogram plots, which we specified up here. It gives a individually different title, which corresponds with the column name and the distribution, which is a very useful tool. And just quickly looking at the distribution, nothing seems weird or off except for the age. So we know that we need to deal with the age. So that's how you do a quick visualization to do explore the data quickly. And again, we're going to be going into more details about the data visualization later in this lecture. Now let's move on and learn about how to clean the data. So let's see. So data cleaning is an essential process in data analytics. It helps us clean out some of the common data issues, such as missing values, duplicates, inconsistent formatting, outliers, and invalid data types. And we like to say that garbage in and garbage out, which indicates or which means that if we have a garbage, basically data set with some issues, our analytics, which is garbage out, will be a garbage. um, so definitely, we want to make the data clean as possible before we do run any deep analytics. And some of the common methods to deal with this erroneous data are following. Either we can drop our rows or columns that contains erroneous data, or we can replace them with a mean, median, mode values. Or we can ignore in our data analytics by filling them with the null values. So these are some of the key options. There are so many different ways data could be erroneous, which means there are many different ways to deal with them. And what I'm presenting here are the most common ways. But again, it's not limited to these options. There are many other options depending on the context, depending on which data type or data set you're playing with, and also how many data that you have. Sometimes you want to go with like replacing um, Radius data with null values instead of dropping them completely because you want to keep other non-null values or non-erroneous data within the same row or columns. So let's learn how to deal with the erroneous values here. So we already discovered some. Let's first look into the employee survey data. So let's take a look at the employee survey data again. And when we run info, we know that we learned that the all the outputs or all the survey results are an object. And we want this to be an integer. Let's take a closer look at why. So when I just see this data set, okay, I do see a numerical values, but I see something interesting here. I see here one of the last row in this data set, the work-life balance of that employee is a dash. Okay, that tells me something. Um, so we can use a value count function that we have learned earlier to look more closely into that column. So if I run the value counts, it's going to show me how many values, what are different types of values within that column. You can see there are threes, twos, fours, and ones, but also few dashes. And just from intuition, we can assume that these dash means non null value, which most likely means that the employee refused to provide the answer, or somehow the data point of those points got um, went missing. So instead of using a dash, which is kind of random and arbitrary, we actually want to assign a null value, which is the option 3 that is shown in this slide. So we can do that by using a replace function. So for replace function, you can either specify that specific column, or you can do that across all the data set by doing something like this. But for now, let's only replace the values dash in this column because I don't know what other columns would look like. So let's try to replace the dash, which is going to be the first input, and the next input will be whatever value that you want to be replacing it with. So we want to replace it with the null values. There are multiple different types of null values in Python, and one that we're going to be using today is NP-NaN. NP stands for NumPy, which is a library that we imported earlier here. And .nan is basically null value version within this NumPy library. So if I just run this value, it just shows an NaN, and that indicates, okay, we don't know what this value is. So we're just going to be replacing this with the dash with this NP-NaN. And now you can see that loss value here is replaced as NaN. However, if you run this column, if you look into this column again, it's going to show that it's actually still dash. This is because you have to assign this replaced list or series back into the data set or data frame. So you basically do a equal sign, basically the work-life balance column equals to work-life balance column, replacing dash with the null value. So when we run that and taking a close look into this column, you can now see it is saved as null value. Let's run the dot describe to see if it actually changed. Nope. The describe still doesn't show this column. Let's take a look at the info. Okay, it is still showing up as an object because even though we changed this dash with the other value, the the pandas doesn't really recognize this as a numerical column. So now we have to manually tell the column, or and you tell the data frame. Now let's convert this column into a numerical column. So you can use as type function to do that. So we're going to be pulling that column and then assigning as type, and we're going to be doing integer. So we're going to be converting that column into an integer. Yep, it shows an error. Why is it showing an error? Um, Interesting. Oh, it's saying that it's invalid literal for an base 10. Okay. Oh, since I tried to convert 2.0 into an integer, the integer function or integer data type really doesn't recognize this format because it's not an integer. So I need to assign a float. Okay, there we go. So now it works. So we have assigned this column as a float value, which is a decimal point numerical value. And similarly, as above, we need to assign it back to the column. And if we run that and let's take a look. Okay, now it's showing that the data type is a float. Let's use an info function to take a look again. Now this converted to the float. And we have to repeat this process for other columns as well, in order to clean up this column or all the columns. And one other interesting thing is that the non-null value has decreased because we have converted some of the dashes to the null value. Therefore, the non-null value count has decreased in the column. So now I just ran out the code to convert other columns into a numerical column as well. It's basically the same functions that I showed before. After I run it, let's take another look into this columns using a describe. Now it shows all three columns plus employee ID with the describe because now everything is converted to the numerical columns. Great. So we're done with the cleaning the employee survey data. Let's see what we need to do with the manager data. Actually, we're good with that data set as well because it looks the data type looks fine, and yeah, I don't think there's much to do there. Now let's look at the DF general data. We have noticed something unusual with this data set earlier. Um, let's deal with this age. So let's look at the age column and let's do a value count. So this value count function outputs a list of all the values that live inside of the age column and how many of those instances are there. And it shows in the descending order. So you can see that 9999 has the most occurrence and the rest have a fewer occurrence. And let's treat this this input or this data point 9999 as erroneous data and basically convert those into a null value as well. We already learned how to do that basically using the same replace function. So instead of replacing dash with the mpnan, we're going to be replacing a 9999 with the null value. So if I run that, it converts 9999 into a null value. And again, I have to assign it back to the same column. By doing that, let's run the value counts again. Now you see there the 9999 value no longer exists because it's omitted there because it's a null value, and the function only shows real numerical values. So that has been taken care of. And one thing that um, that would be interesting to look into is attrition data. So attrition is a column that we are interested in. It is a column that indicates whether the employee has left the company or not. And let's look at all the values inside this column. Okay, this is something interesting. You can see that there are 3,567 cases of no, 579 cases of yes, but however, there are 132 cases of Y and 132 cases of N, which most likely means same thing as yes, and N most likely means same thing as no. In the real case scenario, I would verify this with a data engineer or someone who has a better context in data. But since we don't have that leverage, we're going to be assuming that Y equals yes and N equals no. And we're going to take a same process again to replace those values. Now we're going to be replacing no string, no, actually N string into a no. And then I'm going to do replace on top of this again, or actually to replace Y with yes. Okay. I'm going to be saving this back into the attrition column. And let's take a look at the value counts. Oh, so this is what happens when I don't specify a column with value count. It tries to run the value count for all the columns inside of the data frame, which is messy, and we don't want that. We just want to take a look in the attrition column. So now, okay, looks very clean. We only see a no and yes um, string the inside the column. And okay. And actually, we want to go one step further. So right now, if I do info, this attrition column is showing in as an object. It's basically a string, but I want to convert this into a Boolean, which is a true or false data set or data type, because because I want to use that Boolean to filter out some of the data later. So how would you do that? I would do that. There's multiple ways, but we can do that by basically saying, does it equal to yes? So if the value inside this attrition column is equal to this specific string, then it's going to convert that into a true value. And if the value inside attrition is no, since no doesn't equal to yes, then it's going to convert that into a false. So let's run this and see what happens. So now you can see, so I'm going to be showing you side by side. So the first row is converted to false because no doesn't equal to yes. The second row is converted into true because yes is equal to yes. And obviously, if I do this, all the capital letter yes, then it's going to be showing all the values as a false because this yes with the only Y as a capital letter is different from all the values as a capital letter. So that's something for you to remember. When when you're comparing two different objects, if they're not completely equal to each other, it's going to show false. So I'm going to be using this yes because that's how the data is shown. If I run this, it is showing the output that I am interested in. So I'm going to be saving this into attrition, back into attrition. And now the attrition column is showing a false, true and false. And if I run the describe on this column, you can see that actually not describe, but info. You can see that now the column is converted into a Boolean data type. There are a few other columns that you might want to clean up. But I'll stop here and leave it up to you if you want to continue cleaning up some of the data set. Um, but I'm going to be continuing into the data analytics and convert the data, clean the data later if needed.